Hello, Mastery Algebra 1. I am Mr. Fuller, and in this lesson I will teach you how to solve proportions from Chapter 2, Section 7. Proportions are just equations. They look really like there's a lot of fractions in them because technically that's what a proportion is. It's a fraction equal to another fraction. Usually there's a number missing and we have to solve for it. It's indicated by a letter. And so we're really just trying to get the letter by itself. So there's a couple of different ways to think about it. In problem number 1, if I'm trying to solve for the letter b, I can see that b is divided by 6. So all I really need to do is multiply both sides by 6. That's a simple way to solve that proportion. If I multiply this side by 6, let's think of it as 6 over 1. Then I can multiply this side by 6 over 1. That will cancel out these 6's, so to speak, or 6 divided by 6 will make 1, and we'll end up with b equals, and on the right side, 4 times 6 on the top makes 24, and 5 times 1 makes 5 on the bottom. So that's one simple way you can solve a proportion. That works very nicely when the variable's on the top. That's not going to work in problem number 2 because the variable x is in the denominator. So how do I get it by itself when it's in the denominator? That's kind of awkward. So to do problems like this, we use a different approach. Basically, the idea is I want that x to be by itself, but I don't want it to be in the denominator. I want it to be in the numerator. So I want to multiply by x and get that x off of the denominator. Now, if I multiply one side by x, I also have to multiply the other side by x. So on the right-hand side, the x's would simplify out, and I would just get 68. But now on the left side, if I think of that x as being x over 1, then I can see that I have 4 times x on the top and 3 on the bottom. So it looks like I haven't really solved for x yet. Well, I haven't. I still have a 4 and a 3 to get rid of. Now, we do know that we can multiply that by the reciprocal to get rid of the 4/3. So when I do that, that simplifies out the 3 and the 4 and gives me only the x. And then over here on the right-hand side, I think of that as 68 over 1, and then I can multiply this. Now, I can do the multiplying first and then divide by 4, but I think it's probably easier to divide by 4 first and then multiply by 3. 68 divided by 4 is 17, and 17 times 3 makes 51. So x equals 51 is the correct answer. Now, I know what some of you are thinking. Some of you are thinking, that's a lot different than the way I learned. I learned you do this times this and you divide by this. And that's sort of a magic trick that doesn't always work. For example, when you get to problems like number 3 and number 4, you can see that you can't just do this number times this number and then divide by that number and have the answer. So that's why I didn't teach you that from the beginning. I want you to see these other ways of thinking about proportions that are much more beneficial. In these problems, it's not quite as clear what to do in number 3 because there's 2 places that have the letter b. So what am I trying to get rid of? What should I multiply by? What should I add? Well, one of the simplest pieces of logic for proportions, which really would have worked on both of the other 2, is to use a concept that we call cross products. It basically amounts to multiplying both sides of the proportion by the common denominator. The 2 denominators are 5 and 4, so the common denominator is 5 times 4, which happens to be 20. So really what I want to do is I want to multiply both sides of the equation by 5 and by 4. Now, what does that do for us? Well, basically it gets rid of all the fractions. On the left side, the 5's cancel out, and I have the 4 times b minus 8. On the right side, the 4's cancel out, and I have the b plus 3 multiplied by 5. So now it's a much easier equation to solve, and you should already know what to do. Just distribute, combine like terms if you have any. We have like terms, but they're on opposite sides of the equal sign, so I can't combine them yet. And now we're ready to solve. So I can subtract the 4b, add the 32, subtract the 5b, or subtract the 15. I like the idea of subtracting the 4b because 4 is smaller than 5, and then I'll have a positive number in front of b. That's going to give me negative 32 equals 1b, or just plain b, plus 15. Sorry, that does look a little bit like 16 there. Maybe I'll just write b. And then, to solve for that b, I can subtract the remaining number, which is 15, and that will give me negative 47 equals b. Now, you may be wondering, well, I thought you said you were going to use cross products. Well, let's stop and think about that for a minute. Look at the second line that I wrote. Doesn't it look like I took b minus 8 and multiplied it by 4? And then I took b plus 3 and multiplied it by 5? It's kind of like multiplying on the diagonals. That's why we call this method using cross products. What we're really doing is multiplying by the common denominator, but an easier way to think about it is to just multiply across, multiply along the diagonals. So in problem number 4, that would mean we're going to do n times 6, and that's going to be equal to 5 times 2n plus 4. Let's remember to put parentheses around the 2n plus 4 so it all gets multiplied by 5. So the left side is 6n, the right side is 10n plus 20. To solve that, we can subtract the 20. Actually, that's kind of silly. To solve that, let's get the n on either the left side or the right side. Right now it's on both. I can either subtract the 6n or subtract the 10n. If I subtract the 6n, there'll be no number over here, and I'll have to bring the 20 over. Why don't we subtract the 10n, and then the letter will be on the left side, and the number will be on the right. Even though I'm going to get a negative number in front of n, it saves me a step. So now I just need to divide each side by the negative 4. And I get n equals negative 5. So that's the method of using cross products to solve proportions. You're going to get a chance to practice this in the bookwork here in a minute. But first, let's try one final problem, a word problem. Now, because we know that we're solving a proportion, what we want to do is we want to listen for the two fractions. And as we read the problem, we're going to try to find the proportion. The fraction equals a fraction that this problem is describing. And then we'll solve that proportion using cross products and answer the question. A band went to a recording studio and recorded 4 songs in 3 hours. Did you hear the first fraction? 4 songs, 3 hours. Now notice I put the songs and the hours in there just to remind us that the top number 4 represents the number of songs in that fraction. So that means in the fraction on the other side, I have to remember to put the number of songs on the top and the number of hours on the bottom. So let's keep reading. How long would it take the band to record 9 songs if they recorded at the same rate? So how long, that's like my x. You could use h for hours if you want. You can pick whatever letter you prefer. So now let's ignore the words. I just put those on there to make sure that we got them in the right place. And the proportion we're solving is 4 over 3 equals 9 over x. So now let's use our proportions, our cross products, excuse me. Let's multiply 4 times x, and let's multiply 3 times 9, and those have to be equal. 4 times x has to equal 3 times 9, or 27. So if 4x equals 27, we can solve that by dividing each side by 4, and x will equal 27/4. Now that's an odd way to give the answer to how long, isn't it? So why don't we see if we can simplify that a little bit. 4 goes into 27 6 times, that's 24, with 3 left over. So that's 6 3/4 hours. So let's answer the question. How long would it take the band to record 9 songs? It would take the band 6 3/4 hours to record 9 songs. You could give that answer a little bit different way. 3/4 of an hour is a common way of expressing time. You could say 6 hours and 45 minutes. Remember, if you have a problem in word form, you want to give the answer in words as well. All right, the rest of your work for this lesson is from the book. Remember to do those problems. Do your best, forget the rest. Bye for now.